Most people think big tech life starts the moment you badge through the office doors, but for me it starts much earlier. It starts in the morning rain, navigating traffic, and sitting in transit. It lives in the small, seemingly insignificant decisions we make before the real work even begins. What time do I leave? What do I carry in my bag? What do I eat for breakfast? What do I actively ignore? And what do I protect my mind from before the day rushes in from the outside? This just looks like a normal, everyday commute. But lately, I have started seeing it entirely differently. To my mind, every single day is a complex system. If that system is messy and chaotic before your actual work even begins, the rest of the day becomes infinitely harder. When people see modern tech offices, they usually only notice the obvious things. They talk about the bright signs, the micro kitchens, the endless free food, the specialty coffee, the sleek design, and that overwhelming feeling that every logistical detail is already taken care of for you. To be completely honest, it does feel beautiful. Real work in places like this is not just sitting at a desk with a nice laptop. It is about maintaining the ability to think clearly when you are hit with too many inputs at once. It is a constant bombardment of messages, back-to-back meetings, high-stakes decisions, tight deadlines, and brutal context switching. I work in network automation, and the job has taught me one fundamental truth over and over again. Complex systems do not fail only because of massive, catastrophic problems. They fail because small, minor things are left unmanaged and unchecked for too long. So, I started asking myself a strange question. If I spend my entire day helping automate massive enterprise systems at work, why is my own personal life still running completely manually? This realization is exactly why my desk setup matters so much to me. It is not about looking clean or minimalist for the sake of appearances. It is strictly about reducing daily friction. I do not want to waste my limited morning energy searching for tools or codes. I do not want my workspace to force me into making small, useless decisions. Most importantly, I do not want my immediate environment to create more internal noise than the actual work that is already waiting for me. For me, a desk is not just a piece of furniture. It is a control room. The monitor is positioned perfectly for deep focus. The keyboard layout is built for raw speed, and the empty space on the desk is completely intentional. This setup is not about aesthetics. It is about making the next correct action significantly easier to execute. Food is another critical system that most people rarely think about logically. At first, I just saw it as a massive perk of the job: free food, high quality meals, and zero cooking. But over time, I realized something incredibly simple. The wrong meal can completely destroy an entire afternoon of productivity. Eat something too heavy, and your capacity for deep work slows to a crawl. Eat something with too much sugar, and your focus quickly turns into fake energy followed by a harsh crash. Eat too little food, and suddenly every minor engineering problem feels 10 times bigger than it actually is. So, even my meals became an intentional part of the system, not in a boring or restrictive way, but in a highly practical way. I analyze what helps me think clearly, what slows my brain down, and what gives me sustained energy without stealing the rest of my day. There is a distinct part of me that simply loves building things from scratch. That is why I can stand and watch machines like a 3D printer for long stretches of time. A 3D printer never rushes. It follows exact instructions, layer by layer, executing small, precise movements repeated perfectly over hours. That is the exact engineering mindset I keep coming back to in my personal life. Systems do not become powerful because they are loud, or they become powerful because they are quiet, consistent, and repeatable. There are always moments in the day where everything naturally slows down. The rain pouring outside the office window, the city moving silently in the distance, people walking quietly between meetings, or finding a hidden corner after dealing with too much noise. These specific moments matter. Big tech can make life look completely smooth and effortless from the outside. But on the inside, it is dangerously. You keep accepting just one more task, scheduling one more sync, opening one more notification, and adding one more action item to your mental checklist. Slowly, without realizing it, your brain becomes the single system holding everything together. And in engineering terms, that is a single point of failure. That is dangerous. Humans were never meant to be the only place where important operational data lives. In network automation, our entire goal is to remove fragile manual steps that rely on human memory. In my personal life, I started doing the exact same thing. Write it down, schedule it, prepare it in advance, repeat it, remove the clutter, and automate the process. I don't do this because I want to turn myself into a machine. I do it because I do not want the quality of my life to depend upon unpredictable, random bursts of energy. Leaving the office is also part of the system. Most people think the workday ends when you close the laptop, but mentally it doesn't. The brain keeps running, replaying conversations and remembering tasks. So I treat the end of the day like a shutdown sequence. What needs to be captured? What can wait? What can I stop thinking about? If I do not close those loops, they follow me home and work expands into every part of life. The goal of automation is not to work more, it is to protect what work should not take from you. Time with people, a quiet meal, a walk outside, a moment where you are not optimizing anything. Some moments should stay human. No dashboard, just food, family, a table, a night outside. Automation isn't about saving time, it's about saving attention. Attention is what your best work needs, and it's what your real life needs. This is the system I'm building to protect the parts of life I do not want to lose. This probably looks like a random collection of wires, sensors, boards, and unfinished ideas. But to me, this is not a mess. It is the beginning of a laboratory, a place where ideas can leave the computer screen and become something physical. During the day, most of my work exists inside software. I work with network automation, code, routing systems, and data moving through infrastructure that I may never physically see. The systems are large, critical, and mostly invisible, but when the workday ends, I want to interact with technology in a completely different way. Instead of only writing code for systems that already exist, I want to build something from the ground up. That is where this collection begins. Over time, I started collecting the pieces that could make that possible. Development boards, sensors, breadboards, jumper wires, power supplies, cameras, and small components that may eventually become part of a much larger system. Individually, many of these objects do not appear very impressive. A wire is only a wire. A sensor only produces a reading. A circuit board simply waits for instructions. But once they are connected with the right logic, they can observe the real world, process information, and respond to what is happening around them. That transformation is what interests me. Physical computing changes the way you think. In software, a mistake may produce an error message. In hardware, a mistake can mean an unstable connection, incorrect voltage, unexpected heat, or a sensor producing information that makes no sense. You have to slow down, observe carefully, and understand how every part affects the complete system. You connect something, write a small program, and wait to see whether the physical world responds. Sometimes it works, but that is exactly what makes the process valuable. My office environment is a control room where reliability matters and failure must be prevented. This desk is different. This is a safe place to experiment, make mistakes, disconnect everything, and begin again. The purpose of this space is to test ideas that may fail. learn how the technology really works, and gradually turn a collection of separate parts into one functioning system. Some of this equipment will be used for thermal imaging. Some of it will collect temperature and environmental information. Some will process data, control devices, and provide power to the system. I already have several possible projects in mind, including experiments involving thermal cameras, edge computing, artificial intelligence, and environmental monitoring. But before building anything complicated, I need to understand each part, test it properly, and create a workspace where experimentation can happen consistently. Right now, this is only an inventory, but every working system begins as disconnected pieces. This is the beginning of my home lab, and in the next stage, these pieces will finally start coming together. A few months ago, this exact habit, tinkering, testing, and building systems in the quiet hours at home, collided directly with an incredible opportunity at work. Google announced an AI demo slam. The engineering challenge was intense. Build a real, fully functioning AI innovation and present it live on stage. And it wasn't just to a camera, it was in front of a live room of over 150 brilliant tech minds at Capella in Sentosa, Singapore. Because I had already automated the daily noise out of my routine, and because I had spent my protected hours at home practicing and building physical things, I actually had the mental bandwidth to step up, take the risk, and build something unique for the competition.
Using other AI tools for real-time conversational coaching. So this with Vertex AI will be freely interface for instant and zero-click quality assurance, completely automating the infrastructure delivery cycle. So I'll let them share more on it. Thank you so much.
Thank you. Hello everyone, my name is Teddy and my friend Anand. We are from Google Infrastructure team. So at Google, we manage thousands of data centers and co-location, and we are dealing of physical deployment every single day. And to power the AI revolution, we need to scale our infrastructure exponentially. This is where we hit the classic dilemma, which is speed versus quality, because both are not go hand in hand. And the question is how we can increase the speed of our deployment and installation while we are not sacrificing our quality. And at the same time, the traditional manual inspection is quite subjective and it's quite slow, right? It's imagine like you try to build a luxury car, but you rely on human eyes to inspect all the nuts and bolts. So that's why we start to build Cubic, which is an AI-powered QA assistant that can help engineer on site to verify the installation and everything. So it gives you instant and accurate and objective result. So our engineer can focus on more strategic tasks rather than doing an inspection. How we build this? First, we start with the image of the installation from our historical, and then we train it and we create our own object detection model based on that. And then once the engineer is on site, the engineer will upload a picture or doing a live video screening to check whether the installation is correct or not. And our object detection as a first step to detect if there is any anomalies or any problem on the installation. Then it moves to the second stage, which is we have our Gemini multimodal. It's grounded with our standard of installation to check whether the installation passed or not. And at the same time, we also doing some vision OCR to translate from image to text, and then we compare it with our design document, for example, like that. And last but not least, when the engineer got stuck, we also have our live agent there, live model, that can answer the engineer question on the spot during their physical inspection. Last, we close the loop by putting the feedback back into the system, and we do reinforcement learning for our model, so the model will get better and better when they start it again.
Yeah. Cubic as an ecosystem is entirely built on Google Cloud. We leverage Google storage so that we get enterprise grade security and compliance for all our data. To ensure we scale this application seamlessly without any downtime, we deploy using Cloud Run and Cloud Build. We rely on the powers called Vertex AI for our model generation and image inference. Let us show you a small demo of this. It starts at the dashboard by simply pasting a design. Qubit instantly generates a dynamic step-by-step checklist tailored for this.
My name is Anand. I work in network automation, and this is Anand Automates.